Good morning, students. So today we are starting with the new topic, two-dimensional figures, and we will calculate the center of gravity of 2D areas right now. Let us see some formulas based on two-dimensional figures. Now you can see on your screen what is given to you. There are two geometrical shapes. First one is rectangular shape or square shape. You just concentrate on three values. First one is area, second one is x bar, means x coordinate of center of gravity, and third one is y bar, means y coordinate of center of gravity. Let us see how it works. You just concentrate on this point. This is the center of gravity of the rectangle. Okay, now from the left side, means from the bottom, you can draw x-axis like this, x-axis, and from the extreme left of the figure you always have to draw y-axis like this. So this is the extreme left and bottom, x and y-axis has been drawn. Now from the y-axis, the distance up to this CG like this, it is known as x bar, which is equal to b by 2, and from the bottom axis, x-axis, this distance is known as y bar, which is equal to d by 2, where d means depth of the rectangle and b means width of the rectangle. Area of the rectangle or square will be b into d, that is already known to you. Okay, so this is the simple geometrical shape rectangle. Let us see second shape, which is a triangular element. You can see in the figure. Okay, so this is the triangular element, right angle triangle. Concentrate in this. Where is the base? So this is the base B of the rectangle, and this is the height edge of the triangle. Sorry, triangle. Base B of the triangle and height edge of the triangle. Now, what you have to calculate? You have to calculate the CG. First of all, x bar. It is 1/3 of base. How it comes? So from the bottom you can draw x-axis like this, and up to CG from the y-axis, up to CG, this distance will be 1/3 of base. Okay, this is the fixed formula. We will derive it later on with the help of integration method. Right now you have to remember this is the fixed formula, 1/3 of base. And similarly from the bottom x-axis, distance up to this CG will be 1/3 of height. So it will be 1/3 of base and 1/3 of height. If you calculate from the opposite corner, this distance will be 2/3 of base, means base minus 1/3 of base, that is 2/3 of base. And similarly over here, total height minus 1/3 of height, then it will be 2/3 of height from the upward corners. Okay, now area of the triangle is equal to 1/2 base into height. So these are the two elements, rectangle and triangle. Lots more areas are also there. Let us see about it. The next part will be a circle. Let us check how. Yes, you can see here it is the circular element. Geometrical shape is circle now. You just forgot about this x and y axis. These are symmetrical axis, only nothing else. Now, where is the CG? CG is exactly at the center of the circle. You can draw x-axis from the bottom of the circle, and you can draw y-axis from the left side of the circle. Now, looking from the y-axis, this distance will be the x coordinate, which is equal to radius. And looking from the bottom up to CG, this is also equal to radius. So now, area of the circle is equal to pi r square. That is already available in your 10th standard. Okay, you can see in other words, area is equal to pi by 4 d square. In this, r is equal to radius, in this, d equal to diameter. Now, concentrate on the next figure. It is the semicircle. For the semicircle, you can draw x-axis from the bottom like this and y-axis from the left side like this. You just forgot about x and y-axis for now. This is the center of gravity of the semicircle, you can see. From the y-axis, the distance up to CG is equal to radius is equal to x bar. So x bar is equal to radius only. Now, from this CG up to the bottom of the x-axis, this distance is a fixed distance 4r by 3 pi. Now recall this, in the semicircle arc it is 2r by pi. Now this is not an arc, this is an area. So this distance is 4r by 3 pi. Now area of the semicircle is always pi r square by 2. So this is the formula for the semicircle. Now let us check the formula for the quarter circle. So this is the quarter circle. You can draw x-axis from the bottom like this, and you can draw y-axis from the left side like this. This is the center of gravity, distance from y-axis and distance from x-axis. Both are 4r by 3 pi. You have to remember this formula, 4r by 3 pi. And area of the quarter circle is pi r square by 4. So this is the list of the formula. Now we are going to start numerical. Must remember these formulas of rectangle, triangle, circle, semicircle and quarter circle. Let us see one example and we will see what happens with the method. Okay, let us check the first example over here. What is written? Examples on composite area. Composite means what? More than one parts are combined together to form an object. Suppose in this example, there are part 1 and part 2, means two rectangles are connected together to form a T section. Okay, so what is given in the example? Calculate the center of gravity of T section having flange 20 by 2 cm and width 30 by 2 cm. Now you must remember this. What is flange and what is wave? So here it is given a flange 20 by 2 cm. So this rectangle means horizontal rectangle. Rectangle in the horizontal position is known as flange. And this rectangle means vertical rectangle. Rectangle in the vertical position is known as wave. Okay. So now we have to calculate CG and also show the position of the CG on the figure. Now you must remember this thing, what I am telling to you. Y-axis and x-axis. These two axes you always have to forget because it shows the position of this combined CG. You can see combined CG G. It is after the solution of the numerical exactly. Okay, not before the solution of the numerical. So actually this figure is the simplified figure, not an pre-figure. It is after solution of the numerical. So it will give you answer. So we don't have to check answer first, we have to check question first. So forget these figures. Now according to rule, from the bottom axis you can draw x-axis. Now the most important thing, what is written over here? It is written that the section is symmetrical about y-axis. Now what is symmetrical? Symmetrical means what? If you draw or if you cut this T section exactly like this, then it will show left and right both parts exactly similar. So it means the figure is symmetrical about y-axis, symmetrical about y-axis. Okay. Now if the figure is symmetrical about y-axis, then what happens? Then you have to calculate x bar directly. Now directly means how? So what is the total width of the figure? What is the total width of the figure? It is 20 centimeter. So x bar is equal to 20 by 2, means total width by 2, it will be 10 centimeter. Okay. So x bar is equal to 20 by 2, 10 centimeter, done. Now what we have to calculate? We have to calculate y bar only. Let us see how the y bar is calculated. Let us see on the next page. So yes, this is the same figure in which we have to calculate y bar only. So first of all, what I have done, I have numbered the part 1 and part 2 to two separate rectangles. Okay, dimensions are given to you, 20 centimeter, 2 centimeter, here it is 30 centimeter and this bottom is also 2 centimeter. Now you have to calculate y bar. Okay, so for the y bar you must draw x-axis. So from the bottom of the figure, let us draw x-axis like this. This is the x-axis. Now here it is part 1. So let us check the calculation of this part 1. Okay, part 1. Where is the CG of the part 1? Where is the CG of the part 1? CG of the part 1 must be at the center because rectangle's CG will be at the center. Now, from this CG, distance up to the bottom means up to the x-axis, this distance you have to calculate. So, what it is? It is 30 centimeter plus this half means 2 by 2, 1 centimeter. So, total will be 31 centimeter. You can see y1 equal to 31 centimeter. Now, what is the area of the rectangle? It is equal to 20 by 2. So, it will be 40 centimeter square. Now, what is part 2? In the part 2, the area will be 2 centimeter this and 30 centimeter vertical height. So, area will be 30 into 2, 60 centimeter square. And what is y2? y2 means the CG of this second rectangle. You can see this is the CG of the second rectangle. From this CG up to the bottom, it means 30 by 2, 15 centimeters. So, this is the value of y2. So, basically, these are the calculations of part 1 and part 2 from the figure. Now, let us check what happens with the y bar. So, here it is the calculation of y bar. You can see here it is the calculation of y bar. So, now, for the y bar, what you have to do, formula of the y bar is equal to a1y1 plus a2y2 upon a1 plus a2. By replacing the values from the table earlier, part 1 and part 2, you will get the answer of y bar is equal to 21.40 centimeter. So now, x bar equal to 10 centimeter, which is directly available due to symmetrical figures, and y bar is equal to a1y1 plus a2y2 upon a1 plus a2. According to this formula, you can find y bar, which is equal to 21.40 centimeter. So, this is basically the numerical number 1. Now, let us start with numerical number 2. With this, you can see this is the C section. Find the centroid of the section shown in figure. Now, this section is symmetrical about the x-axis. You know, in the first numerical, the section is symmetrical about y-axis. In this numerical, the section is symmetrical about x-axis. So, what happens? Y bar will be directly available. Now, what is y bar? It is the total height by 2. It is y bar, so total height by 2. So, total height of the figure will be this. Means 2.5, 10, again 2.5. Total will be 15. So, 15 by 2, 7.5 centimeters. So, this is the y bar. Now, we have to calculate x bar. So, let us see the figure. So, okay, so this is the figure in which we have to find x bar. Let us concentrate on the part 1 first. Okay, now, according to the figure, from the part 1, you can see this part 1, 10 by 2.5 centimeter. We have to calculate x bar now, so we need y-axis. Y-axis always passing from the left side, extreme left of the section. Now, CG of the part 1 will be over here at the center. So, from y-axis, this distance will be half of 10 centimeter, which is equal to half of 10 centimeter, which is equal to 5 centimeter. And area of the rectangle will be 10 by 2.5 is equal to 25 centimeter square. Now, concentrate on part 2. In part 2, width is 2.5 centimeter. So, center of gravity will be over here at the center. From y-axis, this center of gravity will be half of this 2.5. Okay, so it will be 2.5 by 2, 1.25 centimeter. And area of the same rectangle, this rectangle area will be 2.5 into this 10 height. So, answer will be 25 centimeter square. Now, let us concentrate on the part number 3. So, where is the part number 3? In the bottom, here it is part number 3. Center of gravity will be at the midpoint, exactly at the center of the rectangle. From the y-axis, this horizontal distance will be half of this 10, means 5 centimeter. Area of the rectangle will be 2.5 by 10 is equal to 25 centimeter square again. So, this is the basically calculation of part 1, 2 and 3. Now, what we have to find? We have to find x bar only. So, for x bar, this is the calculation, the same formula a1x1 plus a2x2 plus a3x3 upon a1 plus a2 plus a3. So, by replacing the value, you can calculate the value of x bar, which shown over here from the part 1, 2 and 3, x bar equal to 3.75. So basically this is the calculation. 3.75 centimeter is X bar with the help of this calculation, and Y bar is available directly due to symmetrical figure. It is 7.5 centimeter. So today we have discussed two numericals about symmetrical about y-axis, and second numerical is symmetrical about x-axis. When the figure is symmetrical about y-axis, you have to calculate only x bar. Okay, reverse. Say in the second sum, when the figure is symmetrical about x-axis, you have to calculate only what? X bar. Okay, so just remember these things. In the next lecture, we will discuss how the numericals are solved for not symmetrical about x and y axis. If the numericals are getting tough, then you will require much more practice. So do practice at your home. Let us see in the next lecture.